lesson, we'll learn how to convert numbers between standard and scientific notations. Scientific notation is simply used to make it easier to write numbers down. We particularly use this for very small or very large numbers. When writing numbers in scientific notation, we must have one and only one non-zero digit before the decimal point. We've already seen how we kind of look at things in scientific notation when we looked at metric prefixes. So we have n times 10 to the nth power. Now, we have two cases. We either have a positive exponent or a negative exponent. So when we have a positive exponent, what that means is that we're dealing with very large numbers. If we have a negative exponent, it's a very small number, so a number less than 1. And in either case, we can have a negative value or a positive value. Here we're only talking about what the value of the exponent is. Let's look at an example. We'll start by setting up the basic structure of our number in scientific notation with one non-zero digit to the left of the decimal point. So we have 4.59 times 10, and then we need to count how many decimal places we're having to move the decimal point so that we can determine what our exponent should be. So I'm going to go over to my number, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So that tells me that I'm going to have the number 8 as the exponent, and it's going to be positive because it is a very large number. So I'll have 4.59 times 10 to the 8th meters. Next, we'll look at an example of a small number. Therefore, it will have a negative exponent. So we have 5.13 times 10 to the, and we've got to figure out what that exponent is. So the same thing, I'm going to count over how many spots I'm moving my decimal place. So I get 1, 2, 3, 4, 5, 6. Remember, we want one non-zero digit in front of the decimal place, and our exponent is negative 6 because it's a number less than 1. So 5.13 times 10 to the negative 6 liters. So you can see the value in writing in scientific notation because you're not having to use all of those zeros, and you're less likely to make a mistake in your values. Let's break this down to make sure we're on the same page of how we set up Let's break this down to make sure everybody's on the same page about the meaning of numbers in scientific notation. If we had the number 2400 and rewrote it as 2.4 times 1000, those are still equivalent values. Then we can break down the 1000 into 10 times 10 times 10. So we have 2.4 times 10 times 10 times 10, and that's going to equal 1000 if we multiply those three tens by themselves. And so what we end up with is 2.4 times 10 to the third because we broke it down into three tens. If I go back and look at my original value and count over the zeros, what I'm going to see is I have 1, 2, 3 decimal places that I've moved over. So I'd have 2.4 times 10 to the third. Let's look at an example where we have a number less than 1. So we have 0.00086. So that's equivalent to 8.6 divided by 10,000. Note that 10,000 is equal to 10 times 10 times 10 times 10. So we can rewrite this as 8.6 divided by 10 times 10 times 10 times 10. And when we do that, we work it out, we get 8.6 times 10 to the minus fourth, which if we look back at our original number and count over the number of decimal places that we would need to move, we see we're moving at 1, 2, 3, and 4. Because it's a number less than 1, we have a negative exponent. What is the value of 3.5 times 10 to the minus 4 in standard notation? The first thing I want to look at is the exponent, which is a negative number. Does this mean it's a small number or a large number? Because it's negative, the value is less than 1, so we have a small number. The first thing I want to do is write out the 3.5 because that's the original number of my problem. And now I'm going to move the decimal place to the left because it's a small number and I know it's a value less than 1. I need to see how many zeros I need to add when I move that decimal place to the left. So we have 1, 2, 3, 4 to put our new decimal place in, which means we're adding 3 zeros on the front. So D is the correct answer. Let's look at some more of these to see how we would write them in scientific notation. So we have 3.5 times 10 to the minus 4th. That's our correct answer. For the first one, we move the decimal point to the left 4 spaces, or 4 places. So we have 3.5 times 10 to the 4th. For B, we move it 5 places. So we have 3.5 times 10 to the 5th. On C, it's a number less than 1, so we know we're going to have a negative exponent. And then we see we're moving it 5 places. So we have 3.5 times 10 to the minus 5th. How should you write 0.00382 in scientific notation? First we ask, is this a small or large number? Is it less than 1 or greater than 1? It's less than 1, so we know we're going to have a negative exponent. And we count over the decimal places we move it, and it's 3 places over. So we get 3.82 times 10 to the minus 3. So whether the value is in standard notation or scientific notation, the numerical value is the same. It's just the way we write it and represent it on paper that varies. So D is our correct answer. When I look at A and B, what I see is those numbers are not in correct scientific notation. Remember, we need one non-zero digit to the left of the decimal place. We never want more than 1 or less than 1, only 1. If I look at C, I do see my 1 digit to the left of the decimal point, which is great, but I have a positive exponent, so that means we have a larger number. And what we're going to see is that we move that over that 1, 2, and 3 places, we get 3820 for the value. What is the exponent when 489,234 is written in scientific notation? Is this a small or large number? Well, it's a large number, so that means we're going to have a positive exponent. Now, I want to go through and count how many decimal places I need to move the decimal point. So I know there's none given, so it means it's after the 4. So now 3, 4, and 5. So we move the decimal place 5 spaces or 5 places to the left. So we get B as our correct answer.